reshape an array in Numpy. Isn't it so cool? We can do this by using reshape function. But the point to note here is we can only reshape for array if the elements required for reshaping are equal in both shapes. We can reshape an 8 elements 1D array into 4 elements in 2 rows 2D array, but we cannot reshape it into 3 elements 3 rows 2D array, as that would require 3 into 3, that is 9 elements. So remember this mathematics whenever you reshape any array. In this example, we have 1D array and we are reshaping it into 2D array of 4 rows and 3 elements in each row. You can see the output here. Similarly, we can reshape any array. We can also convert multidimensional array into 1D array by using this. Now, the next topic is broadcasting. Broadcasting is a quick way to change the values of a Numpy array. Let's understand this through an example. I have this array and I want to change the first 3 values to 50. So simply, I'll use slicing to get the subarray and then I specify the value here. The output should be like this. Now, performing arithmetical operations on Numpy array. Let's understand this through an example. We have 2 arrays here. We can just apply plus operator between these 2 arrays to add them. Just understand, by adding, we means adding each element of one array with its respective, that is, same index element of the second array. Similarly, we can subtract, divide and multiply 2 arrays. We can also add, subtract or multiply all the elements of our array with a particular value, like this in the example. Now, the next topic is to insert and delete elements in the array. We can use insert function which have 3 parameters: the array, the index where we want to insert, and the value. If we want to insert any element at the end of the array, then we can simply use append function. And for deleting any element, we use delete function, which have 2 parameters, the array and the element to be deleted. Now, let's see some mathematical function which Numpy provides. We can use these functions on large data sets and find the answer in just seconds. So, the first one is sum function, which is used to get sum of all the elements in the array. Next is max function, which is used to find maximum element in the array. Similarly, there is a min function, which is used to find minimum element in the array. Now comes the most common things in statistics, that is mean and the median. We can use mean function to find mean of all the elements in the array, that is the average value. We can use median function to find median of all the elements in the array. Basically, median is the midpoint value of the sorted array. So now you might be impressed to know that how magical these functions are for your large data sets. And if you're wondering about the mode function, then Numpy doesn't have mode function. It's in another library. Now, let's jump to the next topic, sorting. Sorting is basically arranging data in a particular format. So, in Numpy, we have sort function, which returns a sorted copy of an input array. Here, the benefit is we can also specify the axis to which we want our array to be sorted. You can understand it better from the example. Now comes the searching. Searching is an operation or a technique that helps you find the place of a given element or value in the list. So, in Numpy, with the help of where function, we can find the index of a particular value we want to search. And the benefit with where function is you can even apply some mathematical operations. Like see this example. Now, search sorted function. It performs a binary search in the array and returns the index where the specified value would be inserted to maintain the search order. Isn't it cool? Now we can insert any element carefree and need not to sort the array again and again. Next, we have count non-zero function, which counts the number of non-zero values in the array. Now, the next topic is joining NumPy arrays. It basically means putting contents of two or more arrays in a single array. In SQL, we join table based on a key, whereas in NumPy, we join arrays by access. We pass a sequence of arrays that we want to join to the concatenate function and our arrays will be joined. Simple. We can also join arrays using stack function. Stacking is same as concatenation. The only difference is that stacking is done along a new axis. We can concatenate two 1D arrays along the second axis, which would result in putting them one over the other. So, we pass a sequence of arrays that we want to join to the stack function along with the axis. And if the axis is not explicitly passed, it is taken as 0. Next topic is comparing. Comparing two NumPy arrays determine whether they are equivalent by checking if every element at each corresponding index are same. We generally use double equals operator to compare two NumPy arrays to generate a new array object. And then we call all function, which will return true if the two NumPy arrays are equivalent. We can also use greater than, less than, and equal to operators to compare. You can see the syntax here. Now, copying. Copy function in the NumPy returns a copy of the array. Now, at last, comes the creative part, the visual representation. NumPy has histogram function, that is graphical representation of frequency distribution of data. Suppose we have this array. Now, if we want to know how many values of this array are available in the interval 20 to 40 or 40 to 60 or whatever. So we can just specify the bin size in this function. That means the intervals, and then use matplotlib library to plot the above things. So this is the resultant histogram. We can actually see how many data points are available in a particular interval. So this was all from my side. I've actually covered all the basics of NumPy. So now what you can do is practice the tutorial and then explore more functions and their uses, as Python is flooded with built-in functions and it is really impossible to learn or to let you learn these many. So just practice and use them as per your need. I hope it was an informative session. Keep exploring, learning and practicing. Thank you for watching this video.